Hello guys. This is the code of a stock trend prediction web app built with Streamlit and using an LSTM neural network for time series podcasting. This app starts by pulling historical data using the Y Finance API, and then the data is cached with st.cache data uh, to improve the performance. So we are only focusing on the close prices, which are scaled between 0 and 1 using the min-max scaler for better neural network performance. In pre-processed data, we generate input sequences where each training sample considers the last 60 days of closing prices to predict the next day. This is a standard setup for LSTM series input. The shape is in adjusted to 3D. Samples times their features as required by the Keras LSTM layers. So the model is defined in get trade model using 2 stack LSTM layers followed by a dense 2.5 and dense 1 layer. It's compiled with mean squared error as a loss function and trained with early stopping to avoid overfitting. So the trained model is saved and reused across sessions. And after training, the model predicts the remaining 10% of the data. Predictions are inverse transformed back to the original price scale. And we calculate the RMSE and MAE errors to evaluate our performance. And in the front end, we visualize our historical closing prices, 100 and 200-day moving averages, and our actual versus predicted prices. And finally, for the forecasting for the next 60 days, we use the last 60 known prices as input and recursively generate predictions day by day, putting each predicted value back into the input window. So all these visuals, charts, and tables are rendered with Matplotlib and Streamlit's plotting API for the interactive experience. And overall, this app demonstrates how deep learning, finance, and web technologies can come together for real-time forecasting. The app just starts by letting users select from the list of popular stocks or even enter your own stocks. So it then fetches the historical stock data from 2015 to 2025 using the Y Finance library and displays the useful visualizations like this closing price and moving averages to give users an overview of the trend. And behind the scenes, the data is pre-processed using min-max scaler and shaped in sequence of the past 60 days of prices to train the deep learning model, which uses LSTM, which is long short-term memory. And it is great for time series prediction. And it is trained on 90% of data and cached for reuse. And once it is trained, it predicts the remaining 10% of the data. And then we compare the predicted versus actual stock price. So the entire app is built in Streamlit, so it is fully interactive, responsive, and easy to use right in the browser. So overall, this is a complete end-to-end solution for stock price trend prediction using LSTM with a clean interface and real-time visual feedback. Thank you.
Hey guys, welcome to our project Stock Price Prediction using LSTM. In this video, we'll explore how we built an LSTM model to forecast stock market trends. We'll go through the core concepts, we'll show you the code, and run a live demo of the project. My name is Mohammad Nadeem, and with me are Rahul, Shreya, and Shana. We all know that stock market trends are constantly changing. They're influenced by a mix of global events, investor behavior, and financial trends. So with this project, we tried to implement an LSTM which can analyze stock data and give us insights into future trends. So to make this possible, we used the following. We used Y Finance to fetch the stock data. We used a min-max scaler to normalize the data for the LSTM, and then used Keras and TensorFlow to train the deep learning model, and then we displayed the outputs using Streamlit and Matplotlib. So now Shana and Shreya will be explaining how the model actually works.
Okay, so in this step, we have focused upon gathering our data and preparing it to train our deep learning LSTM model. So we have collected our data from Yahoo Finance. Yahoo Finance is a data source that contains historical stock prices data. And since our prediction was based on the historical data, we have collected it from Yahoo Finance. And the key features of the data included the data contained high and low prices that would help determine the market volatility. And it also contained the trading volume that would indicate the investor's interest in a particular stock. But then our key focus was on the closing price because that would help us determine or predict the next day's closing price. And our entire prediction was based on the closing price of the stock at the end of the day. And after we have gathered our data, we have gone for data cleaning. We have also ensured that all the missing values are handled, because there can be times when a particular company decides not to trade on a given day or something. There can be missing values also in a data, right? So if those data or rows are not handled properly, it can lead to potential errors. So we have ensured that our data is properly aligned and structured so that it doesn't lead to any null value errors. And after that, we have scaled our data between 0 and 1 for LSTM model, because we know the stock prices generally work on very large prices, and it's going to be quite difficult for LSTM model if we do not normalize the price between a very small value. And in this case, we took between 0 and 1. So for that, we use the min-max scaling normalization to scale the data. And after, so the cleaning and scaling is done, we have also done the training. We have also done the splitting the data into training and testing sets. We have split the data into 90% training and 10% splitting. So that this training set can teach our LSTM model, and then the final 10% testing set can give us the review on how our model works, or if it actually predicts properly. Now, since our data is gathered, collected, and cleaned properly and ready for pre-processing is ready, our model, we have chosen LSTM model for the prediction. We have chosen LSTM because LSTM is a type of recurrent neural network that works on that looks into historical data, and it's a time series data. It's a it can handle time series data. And it's a sequential model, so it would help us give insights about all the previous and then finally predict the next days. So since stock prices is not a random data set and it follows patterns, it's heavily dependent upon the past trends. We used our LSTM model, because LSTM models can remember the pattern better than regular neural networks. Here, how did we made it remember? We fed our LSTM model with 60 days of data from the previous days, and using the previous 60 days of data, our LSTM model could predict the next day's data. So that's how we have trained. We have given the 60 days period for our model so that it would give higher accuracy.
Hello, I am Shreya. So I will be explaining today the training and evaluation and prediction and visualization. So training and evaluation. So model structure, stacked LSTM layers for better learning. And we also used dense, which is that dense is fully connected layers for the output predictions. And we also used loss functions. Loss function, it also measures how far the prediction is from the actual prices. And there is an MSE, nothing but called as mean squared error, which is also used for optimization. Basically, MSE means it's nothing but called as. It also calculates the average square. It also calculates the average square differences between the actual prices versus the predicted prices. And we have performance metrics. So the performance metrics, we have root RMSE and next is NAE. So RMSE is root mean squared error. That is nothing but where it actually shows us the lower values, where this also indicates a better accuracy. Next is MAE. That's nothing but called as mean absolute error, measures deviation for actual values. Next is prediction and visualization. So we for predicting and visualization, we use this we are using interpreting the model's output. The model analyzes the last 60 days of stock prices to predict the next training day. Predictions are visualized using matplotlib graphs, where this matplotlib graphs where it actually measures the actual prices versus the predicted prices for evaluation. It also helps traders to understand the next market movements in the stock price prediction. And our predictions are not 100% accurate, but they show potential trends in stock movements.